The biological transformation triggered by the daily consumption of oatmeal begins the moment the complex carbohydrate matrix enters the oral cavity. Here, salivary amylase initiates the breakdown of starches, but the most significant physiological shifts occur within the stomach and the small intestine. Oats are uniquely concentrated in beta-glucan, a highly viscous, soluble fiber that, upon contact with gastric juices, forms a thick, bioactive gel. This gel increases the viscosity of the stomach contents, which physically slows down gastric emptying. This delay is critical because it provides a sustained stretch to the stomach wall, activating mechanoreceptors that send continuous signals. These signals travel through the vagus nerve to the nucleus tractus solitarius in the brain. This results in the prolonged suppression of ghrelin, the primary orexigenic hormone responsible for hunger. Simultaneously, it stimulates the release of cholecystokin and peptide YY, hormones that induce a long-lasting state of satiety. For the metabolic system, this daily ritual serves as a profound stabilizer of blood glucose. Unlike refined grains that cause a rapid spike, the viscous beta-glucan layer creates a physical barrier. This barrier slows the absorption of glucose into the bloodstream, ensuring a low glycemic response. This prevents the pancreas from being forced into a state of hyperinsulinemia. By maintaining low and steady insulin levels, the body improves its overall insulin sensitivity over time. This is the foundational defense against the development of metabolic syndrome and type 2 diabetes. In the cardiovascular compartment, the daily ingestion of oats acts as a non-pharmacological intervention for lipid management. The liver uses circulating cholesterol to synthesize bile acids, which are essential for fat digestion. Under normal conditions, these bile acids are reabsorbed in the terminal ileum and recycled back to the liver through enterohepatic circulation. However, the soluble fiber in oatmeal binds to these bile acids within the intestinal lumen, preventing their reabsorption and forcing them to be excreted. To compensate, the liver must upregulate its LDL receptors to pull more bad cholesterol from the blood to synthesize new bile acids. This process effectively lowers the concentration of circulating LDL particles, reducing the raw material available for the formation of atherosclerotic plaques. Furthermore, oats contain a unique group of antioxidant compounds known as avenanthramides, which are not found in other cereal grains. These polyphenols exert a specific anti-inflammatory effect on the vascular endothelium. They stimulate the activity of endothelial nitric oxide synthase, which increases the production of nitric oxide. This induces the relaxation of vascular smooth muscle, leading to vasodilation and a systemic reduction in peripheral vascular resistance, lowering blood pressure. As the oat fibers reach the large intestine, they undergo a complex fermentation process driven by the gut microbiome. Since human enzymes cannot break down the structural polysaccharides of the oat, these fibers serve as prebiotics, specifically nourishing beneficial bacterial strains such as Bifidobacterium and Lactobacillus. The fermentation of these fibers by the microbiota produces short-chain fatty acids, primarily acetate, propionate, and butyrate. Butyrate is of particular medical importance as it serves as the primary energy substrate for colonocytes, the cells lining the colon. By providing a consistent supply of butyrate, daily oat consumption strengthens the intestinal mucosal barrier, enhancing the tight junctions between cells and preventing the translocation of endotoxins into the systemic circulation, a phenomenon often associated with chronic low-grade inflammation. This improved gut environment also modulates the immune system, as approximately 80% of the body's immune cells are located in the gut-associated lymphoid tissue. The presence of beta-glucans has been shown to enhance the activity of macrophages and neutrophils, increasing the body's innate ability to recognize and neutralize pathogenic threats. On a micronutrient level, the daily intake of oatmeal provides a concentrated dose of essential minerals that support a vast array of enzymatic reactions. The high magnesium content acts as a cofactor for more than 300 enzymes, including those involved in glucose metabolism and DNA synthesis, while also acting as a natural calcium antagonist to support healthy muscle contraction and nerve conduction. The manganese found in oats is critical for the formation of connective tissue, bone matrix, and blood clotting factors, while also playing a key role in fat and carbohydrate metabolism. For individuals concerned with hematological health, oats are an important source of non-heme iron, combined with steady B vitamins like thiamine. It supports the efficient production of red blood cells and cellular energy production within the mitochondria. This prevents the iron deficiency, anemia, and fatigue often seen in restrictive diets. The dermatological and neurological effects of consistent oat consumption are equally significant. The silica and zinc present in whole oats are fundamental for the structural integrity of the skin and the synthesis of collagen, leading to improved skin elasticity and faster wound healing. Neurologically, the steady supply of glucose ensures that the brain is never subjected to the cognitive deficits associated with hypoglycemia. Furthermore, oats contain significant levels of tryptophan, the precursor to serotonin. When blood sugar is stable, tryptophan can more effectively cross the blood-brain barrier, leading to improved mood regulation and stress reduction. However, the medical efficacy of this daily habit is entirely dependent on the structural integrity of the grain. Steel-cut and rolled oats preserve the fiber-rich bran and the nutrient-dense germ, maintaining the slow-release carbohydrate profile. Conversely, highly processed instant oats are often pre-gelatinized and stripped of their structural complexity, leading to a much higher glycemic index and a diminished capacity to bind bile acids. Therefore, for the maximum therapeutic benefit, the grain must be consumed in its least processed form. When integrated correctly, daily oatmeal functions as a multisystemic regulator, optimizing digestive transit and enhancing metabolic flexibility. It clears arterial pathways and fortifies the gut immune axis, representing an effective strategy for preventing chronic diseases. Over 30 days, the reduction in systemic inflammation and stabilization of hormonal pathways create a physiological environment of homeostasis, characterized by improved lipid profiles, stabilized blood pressure, and a robust intestinal microbiome. This is not merely a nutritional choice, but a consistent biochemical intervention that supports longevity and vitality.